guys might know me. I've filmed a lot of videos on quarks and leptons and stuff on this channel, and of course on other channels. I've done reactions, I've done video games. Harry's channel, I've done like face reveals. If you guys haven't seen that, go check it out. It's a Monk Gaming. No space between A and Monk. Anyway, today we're going to be talking about electrons and how they really help make everything possible. Alright, so let's start off with what an electron is. Is a negatively charged electric particle, which means that it has a negative electric charge. Now, some people I've heard in certain schools don't believe that negative really comes in handy. However, in this case, it really does. So let's take a look at the model of a atom where this basically comes in handy. So a proton, which is in the middle of a atom, has a positive charge, which means it has, I think it's a positive charge of 1. Electron has negative 1. So I believe that this atom, if it's number 6, it would be, I think that boron? I think that this one's boron. I could be wrong. No, it's the one after boron. I don't know. I'm not really an expert on the periodic table. But, hang on one second. Alright, sorry about that. But an electron is basically the opposite of a proton, except the proton has a mass of 1, and an electron has a much smaller mass. Now, mass is not gravity. Mass is not weight. I will be going over this in another video, but just to say this now, mass is not weight. Mass is the amount of something. So, an electron has a lot less mass than a proton. These gray particles are neutrons, which have a neutral charge, which means they have 0 charge, or about 0. I don't believe, actually they might have perfectly 0. Alright, so as you can see from this model, electrons usually go around the protons. That's not always true. There are some electrons that definitely go through particles at different rates and stuff, but most of the time it is electrons going around atoms, or neutrons and protons. So, how does this tie into everything that we know? Now, to make compounds, which are mixes of elements, you need electrons. Valence electrons. Let's talk about a valence electron. A valence electron, here, this is the best actual example for this. This is a graph of a regular atom. It's probably one that you've seen in school before, or something like that. These 2 electrons are in the first stage, or the first row. There can only be 2 electrons in the first row. In the next row, there's 8. The next 16, and so on. I'm not going to talk about the other rows because it's a waste of time. If in the first 2 rows, let's say usually there are the same amount of protons as there are electrons. Usually. That's not always the case, but usually. Let's say that these 2, let's say that it was a helium that has 2 neutrons, 2 electrons, and 2 protons. So, it'll have 4 in the middle, 2 on each side, without this one. Sorry about that. Can't find a better model. I'm not good at this. But let's say that these 2 are the farthest out. They're on the first row, but they're still the farthest out. Those are the valence electrons. The valence electrons are on the farthest out row possible. So here, since we have 3 protons, there are 3 electrons. So one of them is on the farthest row. Now this row, this is now this row is the final row, and this is the valence electron. Now, what do valence electrons do? Alright, so I'm going to quickly check what number I was right on for number 6. It was carbon. I'm out of my mind. So, valence electrons, actually this is a really good one. Shared electrons. Sometimes, and usually it's actually a lot more often than sometimes, but atoms such as, we'll say, just for the example of this, we have carbon and oxygen. They pull each other, the nucleus, which is what the middle or the protons and neutrons are called, pull the other electrons close together. So The outside electrons on each of them will form a bond right here. Now, this ends up meaning that both of the atoms share the electrons instead of one of them getting them. That means it forms a bond and creates a whole new substance. So this would be carbon oxide, which means that this is a whole new compound, which, as we talked about before, was a mixture of atoms. Excuse me, 1 second. Okay, so now you're starting to see how this ties to how everything is built. But you still don't really understand, do you? The thing is, these can work in multiple ways. There could be another, let's say, oxygen attached up here, or another carbon over here. It could have, I believe that it's only in a hexagonal shape depending on the atom, but it could have almost an infinite amount because each one can be connected to another, like 2 or 3, or maybe even 4. Which means that's how atoms form into bigger things, such as cells, which are the building blocks of humans, which are the building blocks of society, which are the building blocks of unity. So in the end, these little electrons that we can't really see right now are the building blocks for the entire universe. Hope you guys enjoyed. Please remember to like and subscribe. See you guys next time.